Welcome to this presentation. In this module, I'm going to speak about mobile IP, agent discovery, and then dynamic source routing and DSDV protocol. The internet is the network for global data communication with hundreds of millions of users. So, why not simply use a mobile computer and the internet? The reason is quite simple. You will not receive a single packet as soon as you leave your home network. So the goal of mobile IP is to allow the users to move from one network to another without changing its IP address. It enables us the transmission of data packets efficiently without any packet loss and disruptions. Here are some of the terminologies used in mobile IP. Mobile node. A mobile node is an end system or router that can change its point of attachment to the internet using mobile IP. Home network, it is nothing but the network for or subnet the MN belongs to with respect to its IP address. Home agent, the home agent is responsible for providing several services for the MN and it is located in the home network. The home agent can be implemented on a router that is responsible for the home network. If changing the router software is not possible, the home agent could also be implemented on an arbitrary node in the subnet. Foreign agent is the agent that can provide services to the MN during the visits to its foreign network. The foreign agent can have the COA, that is care of address. Care of address defines the current location of MN from an IP point of view. All IP packets to the MN are delivered to the COA, not directly to the IP address of the MN. Packet delivery towards the MN is done using the tunnel, and to be more precise, the COA marks the tunnel endpoint. The COA can be of two types, foreign agent COA and co-located COA. Now let us see how the mobile IP works. Suppose a correspondent node wants to send an IP packet to the MN. One of the requirements of mobile IP was to support hiding the mobility of MN. CN doesn't know the MN's current locations and sends the packet as usual to the IP address. This means that CN sends an IP packet with the MN as destination address and CN as source address. The home agent, that is the HA, now intercepts the packet knowing that MN is currently not in the home network. The packet is not forwarded into the subnet as usual but encapsulated and tunneled into the COA. A new header is put in front of the old IP header and then it is forwarded. The foreign agent now decapsulates the packet and removes the additional header and forwards the original packet with the CN as source and MN as destination to the MN. Again, the MN mobility is not visible. It receives the packet with the same sender and receiver address as it would have done in the home network. At first glance, sending packets from the MN to the CN is much simpler, but the MN sends the packet as usual with its own fixed IP address as source and CN's address as destination. The router with the FA acts as default router and forwards the packet in the same way as it would do for any other node in the foreign network. As long as the CN is in the fixed network, the CN were also a mobile node residing in a forward foreign network, the same mechanism would apply now in other direction. One initial problem of the MN after moving is to how to find a foreign agent. How does the MN discover that it has moved? For this purpose, mobile IP describes two methods. One is agent advertisement and the other is agent solicitation. In the agent advertisement method, foreign agents and home agents advertise their presence periodically using special agent advertisement messages. And these advertisement messages can be seen as beacon broadcast into the subnet. Agent solicitation will be sent by the mobile node when the MN doesn't receive any COA. The agent's advertisement packet with extension of RFC 1256 for mobility will be used. The upper part represents the ICMP packet while the lower part is the extension needed for the mobility. The fields that are necessary on lower layers of agent advertisement cannot be seen, but clearly mobile nodes must be reached with the appropriate link layer address. And the TTL field of the IP packet is set to 1 for all advertisements. So as you can see here, the upper packet is the Internet Control Message Protocol and the lower part is the extension needed for the mobility. And these are the field in the upper part, that is type, code, addresses, lifetime, router address and preference list. For example, the type will be always set to 1 and code will be 0 if the agent routes traffic from non-mobile nodes also, otherwise it will be 16. Okay. And these are the list of fields that are included in the fields for extension of mobility. And in case MN doesn't receive any of the advertisement messages, it can request the service by sending the solicitation message to inform the FA directly. And this solicitations are again based on RFC 1256 for router solicitations, and care must be taken to ensure that these solicitation messages do not flood the network. But basically, the MN can search for an FA endlessly sending out solicitation messages. And tunneling is nothing but a virtual pipe of data packets between a tunnel entry and tunnel endpoints. Packets entering the tunnel are forwarded inside the tunnel and leave the tunnel unchanged. A tunnel establishes a virtual pipe. Here, the encapsulation is the mechanism of taking packets consisting of packet header and data and putting into the packet the data part of new packet that you can see in this diagram. The reverse operation, that is taking a packet out of data part of the another network, is called as decapsulation. So encapsulation and decapsulations are the operations typically performed when a packet is transferred from a higher protocol layer to a lower layer or from a lower to higher layer respectively. Here, HA takes the original packet with the MN as destination and puts it into the data part of new packet and sets the new IP header in such a way that the packet is routed to COA. The new header is also called outer header for obvious reasons. Additionally, there is an inner header which can be identical to the original header, as this is the case of IP and IP encapsulation. There are three types of IP and encapsulation. That is, IP and IP encapsulation is mandatory, whereas the other two are optional. In minimal encapsulation, it requires less overhead but requires changes to the original header. In generic routing encapsulation, it allows the packets of different protocols to be encapsulated by another protocol suite. In dynamic source routing, the source sends a broadcast packet which contains a source address and destination address, request ID and path. If the host saw a packet before it discards it. Otherwise, the route looks up into a route caches to look for a route to destination. If it doesn't find, it appends its address into the packet and then rebroadcast it. The route should be maintained, that is, whenever a node transmits a data packet at route replay or route error, it must verify that the next hop correctly receives the packet. And in destination sequence distance vector, it is a hop by hop vector routing protocol. Each node will be periodically broadcast by routing updates, and this is a table driven algorithm. Each node in the network maintains a routing table that has entries for each destination in the network and the number of hops required to reach them. This is the diagram that shows the links between the different nodes, and the last figure shows you the vector table, that is the number of hops required is placed under the column metric, and the next router is shown in the third column. Thank you.